So welcome to Hudson Alpha's campus. Welcome to our final Hudson Alpha U night of 2024. For those of you that have come to some of these U nights before, welcome back. And if this is your first time joining us for a U night, I'm so glad that you're here. And if you haven't met me, let me introduce myself to you real quick. So I'm Kelly East, and I have the pleasure of being the Vice President for Educational Outreach here at Hudson Alpha, which means I get to be the chief cheerleader of all of our education activities, and I get to connect with you guys, our community, through events like this, which is just the most fun to help engage with you and get you excited about genetics that we get to come and kind of live within every day here at work, and specifically talk about how genetics affects our lives day in and day out. So tonight's Unite event is all about understanding family health history, which is uniquely personal to each of us. You may have come in tonight kind of thinking, oh, I hope I get some questions answered and about your particular history. My hope is that as we kind of go through this tonight, we'll kind of get to frame, like, how do you think about your family health history, and what are the questions that you should be asking as you reflect on your family members, the stories you have with them, and what you know about their health, and what that means for you as you think ahead towards your potential development of maybe similar diseases in the future or not. So as we jump in, I want to introduce you. I'm going to get a little bit personal. That's what family health history is. And I would love to take a second and introduce you to two women in my family health history that have certainly a big impact in who I am, one of whom I knew really well, and another that I didn't get a chance to know. And so let me first introduce you to this woman. This is my mom. You can maybe see a resemblance. I don't know. Yeah, this is my mom. And as an only child myself, my mom was my favorite playmate when I was little, and then really turned into my best friend as I got older. I had my mom for 19 years, at which point she passed away of a brain tumor when I was starting my sophomore year in college. She actually was diagnosed with that brain tumor a decade earlier when she was just in her mid-30s. But she was an incredible woman. And then this lady right here, this is my paternal grandmother. So this is my dad's mom. And this is the one that I never got a chance to meet. She was diagnosed and then very quickly thereafter passed away of breast cancer when she was in her mid to late 60s. She passed away just a year and some change before I was born. And I tell you these two stories because I want to be, and we'll kind of circle back to this at the end, about what do these mean for me, these family histories that I have to kind of wrestle with, what that means for my health moving forward. But if I were to chart them on my family health history, which that's what tonight's all about, so let's define it. Your family health history is the record, it's the chart, it's the information about your family members and their health and disease story. What they were diagnosed with, what things ailed them, how old they were when they passed away, what did they pass away from. That's your family health history. Whether you have it in a really pretty genetics-y chart at home, I do, or whether it's just in a logbook, right, where you've got all that information written out, no matter what form it takes, that's your family health history. And so this is the super kind of zoomed in view of my own family health history. And so without boring you with all the ins and outs of my history, here's these two pieces of information. So here's me, and here's my mom. And it says that she had a brain tumor diagnosed at 36 and passed away at 46. And then here is my grandmother up here, my dad's mom, who was diagnosed and passed away from breast cancer, both at 68. Although the running thought is that it was incredibly advanced at that point. She probably had it for a long time before. And And maybe you've got a similar history where the further back you go, the more fuzzy that family history gets, right? That our ability to diagnose disease and to document it is a lot better today than it was a bunch of years ago. But that's my history, and when we, kind of the teaser, when we circle back to this at the end, one of these two pieces of my history matters more in terms of my own risk, and it's not the one that's closer related to me. So we're going to talk about family health history, and the reason that I care about mine, and probably the reason you came here tonight caring about your family health history, is because you want to know, what does it mean for me, or what does it mean for my children or my grandchildren? How can that help us better be informed and hopefully better kind of be proactive against those risk factors that might be there because of your history? So I want to anchor this in this kind of this progression of, for anyone to get sick, there's this movement from being healthy to having disease, and that's a progression. And so to kind of anchor that, before you get sick and you are kind of sitting in this early stage, the stage of what the CDC calls the stage of susceptibility, right? Where you could get sick, and you're, over the course of your lifetime, you're accumulating, you're gathering risk factors. Some of those maybe you were born with that are encoded in your DNA, but then others of those are being added on as you go through life and are accumulating more risk factors with your environment, with your lifestyle, right? That you're sitting in that stage of susceptibility. And ideally, you stay here forever, right? That's where you hang out. But at some point, enough of those risk factors accumulate that shifts a person into, at least inside their body, shifts them into they're heading towards a disease state. Things in your body are not working like they should be. If you could zoom in and you could look in what's happening inside your body, things are starting to go awry. You may not be having any symptoms yet, but you are moving down that pathway from health to disease. And then you move on through and you actually develop clinical symptoms. At some point as you move through this process, you get diagnosed, which hopefully is the minute you start having symptoms, but sometimes that can lag a fair amount. And then ultimately you are either going to recover or not from that disease. But tonight's talk is all about what's happening in this area right here, where you're sitting in the stage of susceptibility and gathering risk factors and trying to, for us tonight, using our family history to figure out where we are down this path and what are our risks, and how can knowing about what's happened in the past in our family, how can that help inform the future? And so as you're sitting in that stage of susceptibility, you've got these risk factors, and this is kind of the world's easiest test, right? The minute you see all of the above, you just, right? Yeah, that's test taking 101, right? So what are these risk factors that can lead someone from health to disease? Well, the environment that we live in can contribute to our risk. The things that we do, the lifestyle choices that we make, what we eat, how much we exercise, how much sleep we get at night, and then also things that are happening inside our DNA that we were actually born with, often, that were passed to us from our parents. But all of these things together contribute to whether or not we're going to get sick. So yes, D, all of the above. So as we go through tonight, you notice there's jars up here on stage. You also, as you walked in, those folks that are in the room, you are now holding hopefully a fuzzy little craft palm that I promise we'll get to at some point in just a few minutes. But as we think about our risk for disease, we're going to be using this jar analogy a lot. So the way to think about this, there are lots of diseases out there that you could potentially develop in your life, and your risk for any one of those has a jar. And at the top of that jar, you've got a threshold. There's a line, right, that as your jar gets filled with risk factors, if you cross that line, what do you think happens? You get sick, right? You cross from health into a disease state. And so you are, over the course of your lifetime, you are filling up that jar, and as long as you don't cross that jar during your lifetime, you're not going to get that particular disease. But if you cross the line, you are. And we're largely going to talk about risk factors in two big categories, right? We've got genetic risk factors. Those are the things that are changes in your DNA that put you at a higher risk than the average population for a disease. And there's environmental or lifestyle risk factors, right? Things that are outside of our DNA that contribute to our risk of disease. So those are the two types. And there's lots of different ways that jars can get filled depending on what disease it is. And all diseases are not created equal in terms of how risk factors play in there. That you can have diseases that their jars look like this. The whole thing is one big environmental risk factor, right? Like perhaps this friend or enemy, this is influenza that might be visiting some of our houses, hopefully not, over the coming months. But developing the flu is completely environmentally driven, right? That is an example of a jar that is completely filled with one big yellow craft palm. Or there are diseases out there that their jar looks like this, where it is one big blue craft palm, right? That there's one single spot in your DNA that is a yes or no. Are you going to have that disease, or are you not going to have that disease? Those exist. These are usually really rare. So most of the diseases that you're going to see in your family history do not look like this. One that does, that you might have heard of, is a disease called Huntington disease. I see some nods in the room. Huntington disease is a neurological disorder where there's a change in the DNA, right, that makes your body, a person with Huntington's disease, it makes their body create a protein that it shouldn't be making, or in a way that it shouldn't be made, that causes toxins to accumulate and build up in your neurons. It's not good for neuron function, but the accumulation of those toxins in the neurons cause that disease that includes problems with movement and balance and mood and communication, and it's a degenerative disease that gets worse over time. So Huntington's disease is an entirely genetic disorder where you can look at a specific place in your DNA and say, yes or no, are you going to get Huntington's during your life? So one single big blue craft palm. And so in those cases, the genetics is really easy, right? If someone comes to me and says, I've got Huntington's disease in my family, here's what my family history looks like, what's my risk? This is super easy. I can tell them quickly it's 50%, right? Because this dad who has Huntington disease is either going to pass off the copy with the change or the copy without. It's simple Mendelian Punnett square genetics here. And if everything were that simple, genetic counseling would be a lot easier. But the fact of the matter is the vast majority of diseases that affect humans are not like those two examples, where it's one single risk factor that controls a disease one way or another. Most human disease is not entirely genetic or environmental. It's a combination of both, and it's the combination of a lot of both. And so as we think through how can the jars look for other types of diseases, I want to walk through some examples, and I'm going to use these props up on stage. We've had arts and crafts hour in educational outreach this week, right? To walk through some examples of how the genetics can play out when it's not that simple. Genetics plays a role, but it's not the entire answer to disease development. So this, up on the screen, this jar, or this looks a lot like this one over here. What do you notice? We've got one pretty big blue fuzzy craft ball, right? But it doesn't go all the way up. So this person, and the blue ones are the genetic pieces that someone is born with. So the minute that you are born, your jar is that full. But it's not all the way up. There are still other things that have to happen from either genetic or environmental factors that would actually get someone to cross that line and develop disease. But they have, compared to an average person, they have a much higher risk of disease. An example of this that is one that gets talked about quite a bit is the story of the breast cancer BRCA1 and BRCA2 genes. This is an actual screenshot of a paper that was published way back in 1988, where this woman right here, this is Dr. Mary Claire King. If you guys were at the most recent Hudson Alpha Tie the Ribbons event, or if you weren't at that, I think you can go watch parts of that online. She was actually here talking that she is a phenomenal scientist and mathematician who studied and worked with a whole bunch of families that she looked at their pedigree, she looked at their family histories and said, this cannot be random chance. There is so much breast cancer in these histories, there's got to be something going on underneath that. It has to. Mathematically, it is implausible that this is random chance. And then from that, she then helped contribute to the discovery of these really big breast cancer risk genes. Not terribly long later. So this is a classic example of this situation where people who have changes in BRCA1 or BRCA2, they're not born with cancer. There are some people with those changes that'll live their whole life and not develop cancer. Not many of them, but some, right? But their risk is significantly higher than the general population. So she was studying family histories that look like this. This is striking. You notice incredibly early, these are breast cancers diagnosed in women's 30s. Those are actually males, men over here that develop breast cancer. Yeah, this is not a typical family history. And so there was a whole set of these families that she was looking at saying, there's got to be something going on. And then ultimately when they discovered those genes and what they meant for people who have them, this is what they found. So the green bars, that's your general population risk of disease, and then the pink and the blue, this is BRCA1 in the pink and BRCA2 is in the blue. And you can just appreciate the significantly higher risks, especially for breast, also ovarian, male breast cancer, prostate, pancreatic. There's some other cancers too that it increases risk a little bit. But if this is going on in a family, that family history is quite likely going to show that if you know your family history. We'll talk about that a little bit as well. But this is an example of a really big genetic risk factor for disease. Now that doesn't just happen in breast cancer. There are other of these really big blue risk factors for things like colon polyps and colon cancer, for having very high levels of cholesterol, especially when that happens early on in life before the typical age of high cholesterol is, or heart problems. So individuals, if someone has a family history that has people in it that have rhythm problems, arrhythmias, or this is a picture right here of a heart with a type of cardiomyopathy where the actual heart muscle, the walls are thick. maybe that looks a little bit atypical from what you expect hearts to look like. Those are other examples of things that would kind of be red flags in a family history, that there are genes that if you have changes in them can significantly increase your risk for those kinds of diseases. Or a jar can look like this. So this looks more like this prop over here, where we've got one risk factor here that's pretty big. It's kind of more of a medium-sized genetic risk factor for disease. So it increases your risk significantly, but not nearly as much as the one over here does. But it's filling your jar up. This individual over here was kind of at baseline when they were born. Their jar is fairly full, one with one really biggish risk factor and then several smaller ones as well. A couple of examples of how this plays out. There's a gene called CHEK2 that also increases risk of breast cancer, not like BRCA1 and 2 does, but women who have changes in this CHEK2 gene, their breast cancer risk goes from 12% at baseline, that is just an average woman's lifetime risk of breast cancer, up to 20 to 25%. So it about doubles it. So that's significant, but if you are that woman's doctor, or you are that woman, the way you think about your risk is different if it's 22% versus 70%, right? The way that gets managed can be different, but this is enough of a risk, 20 to 25%, that is noticeable and is worth paying attention to and managing differently. To get out of the breast cancer storyline, another example of this type of risk factor is a gene called ApoE. And ApoE is associated, having certain changes in that gene, it's associated with an increased risk for Alzheimer's disease, where individuals that have these particular versions of this ApoE gene, depending on whether you've got one copy of that risky version or two copies of the risky version, your Alzheimer's disease risk heads up towards 29 to 35% over your lifetime. Average risk is about 15. So again, it shifts that needle up, but it's far from deterministic. And so when you look at family histories, sometimes you might see things that look like this with breast cancer, where you've got a couple instances of it, probably more than just you might expect in an average person's family history, but the ages aren't quite as strikingly young. It doesn't follow a pattern where you can clearly see something tracking through every generation. Or this case where you've got a grandparent with Alzheimer's that is not at a terribly young age. These are things where you could see a family history like this and wonder, is one of these kind of risk factors at play that's moving that needle up a little bit, right? But is not a huge risk that's being passed through that family. And then really, there are tons of diseases that fall into this category right here. Things like coronary artery disease, type 2 diabetes, mental health conditions, autoimmune conditions. We're checking a lot of boxes here that are really complicated, where when we look at what goes into those diseases, it is a whole bunch of tiny factors that all play a small role, both genetic and environmental. These are a lot harder to track down than the big ones, right? That just kind of scream at you from either mathematics or doing genetic testing. So here's a graphic. This is actually from 2015. So if I imagine if we redid it, this would have even more genes on it. But this has a lot of kind of garbly-goop up here, right? Every single one of these is a gene that's associated with coronary artery disease. Yeah, there are tons and tons and tons of them. This is not a one-piece puzzle, right? That in all of these genes, there are changes in the recipe that can move someone's risk up a little bit or down a little bit. And so for you to try to get a handle on someone's risk for one of these diseases, you've got to pay attention to a lot of different places, some of which we know and some of which we still don't know. So I want to dig in to a little bit of science here and get a little bit more in the weeds. And then after we get through this, we're going to do our activity. So hold with me for just like a minute and a half as we get a little bit nerdy. Because the reason I want to go here is you, like I, might read news headlines a lot that say, new gene found for diabetes, coronary artery disease, right? You name it, right? That makes the headlines, new gene was found. And you, like I, think, oh great, they found one of these. That would be a big deal. And then if you actually went and read the fine print of the science that happened, they found one of these. Now, that's important. I'm not trying to diminish that finding, but that impact on a patient finding one of these is not huge, right? And so I want to kind of teach you what to look for in those papers to try to understand how big of a deal it is that they have just stumbled upon this new association between a piece of DNA and a disease. So when we think about a risk factor in a disease and how strongly it's associated, essentially how big is the puffball, there's this term called odds ratio that is often connected to that. That's how they quantify, that's how they tell you how big the puffball is. And odds ratios it's a measure of how strong the association is between a risk factor and a particular outcome, in this case, getting sick. And odds ratios are thought about as being on a number line, where if you have a risk factor where an odds ratio is exactly 1, that means there's no association, right? It doesn't move your risk up, and it doesn't move your risk down. Knowing that information does not at all inform your risk of disease. So if 1 is neutral, any odds ratio that is higher than 1 is going to move your risk up. Anything that's less than 1 is going to move your risk down. That's a good thing, right? It's going to actually protect you from that disease. And so when an odds ratio, and the further it is from that 1 number, the more impactful it is. So an odds ratio of a 1.1 moves your risk up just a little bit. An odds ratio of a 1.5 would move it up more. Odds ratio of a 2 or a 5 or a 10, right? Those are all getting, the craft palms are getting bigger and bigger and bigger. And it goes the same on the other way, where if you have an odds ratio of a 0.9, that moves your risk down just a little bit. Odds ratio of a 0.5 moves it down even further, right? Number line. For many of these really common diseases, like coronary artery disease, definitely got some of it in my family history, bet a lot of us do. For things like coronary artery disease and that slide that had all those genes listed, right? For the vast majority of those, the odds ratio attached to them is between 1 and 1.5. They're small, right? These are tiny, tiny little craft palms that are being found. And so that's, as you hear about new discoveries, and it's super important to find all of these, and if at some point we know enough about them, we could start putting them together and actually giving a person a much better, accurate description of their risk. Right now, with a lot of those diseases, there's still a lot of gaps that we don't have. Okay, so what I want to do, and this is a little bit of an experiment for me too. We're going to see how this works. In just a minute, we're going to do a live simulation of a whole bunch of hypothetical people and hypothetical diseases. The way this is going to work is, well, first I want to make sure that everybody that's in the live audience in here has a craft palm in your hands? Yeah. Does anyone not have one? Or you didn't get one, or somewhere between there and right now it's gotten lost? Does anybody need one? Raise your hand if you do, and we'll bring you. Okay, so the way this is going to work, in just a second when I say go, some of the amazing members of our education team are going to bring to everybody on this side of the room, they're going to hand that person a jar, a mason jar that has a line, a piece of tape across the top. And y'all on this side, what I want you to do is put your craft palm in there and pass it down. And we're going to go all the way down to this side of the room, putting our craft palms in those jars, and you guys on this end, hold on to it so we can talk about it. All right. All right, so down here, we have some jars. It looks like we've got some full jars. Y'all really went after the big craft palms when you came in. Yeah. So those folks, and some of the rows had fewer people too. So if you're on this side, if your jar is all the way, if your person got sick, raise your jar up in the air. Ooh. So we can all go, ooh. Okay. All right. So now for the others whose jar, anybody not have a jar get filled? Yeah? All right, hold those up. Okay. Okay. And just by looking at them, there's some jars that are very blue, and there's some jars that are very yellow. Yeah. Now, what we just did here tonight, this was totally random. You had no idea what you were doing when you were picking craft palms out of a bucket. Life is not that random. For each of us in our jars that represent all the different things that we might develop in our lifetime, the blue craft palms are things that we were born with, right? That was usually from mom or dad, right? Those are inherited. Those are things that we can't really change. But then the yellow pieces are things that maybe some of those we can't change either, but some of those that we can, that are those environmental and lifestyle pieces as well. You had some that were really big. There were a few. Those went real fast. Those big, fluffy pom-poms that looks like this. Right? Some of y'all are going, ooh, that's pretty. That wasn't still in the bucket when I got here. But then some others were teensy-tiny, right? But there are lots of ways that a person's jar can get filled, right? You could have an entire jar that's filled with nothing but tiny, tiny risk factors, but there's enough of them that crosses that threshold. Or you can have a situation where you've got a giant risk factor that was encoded in your DNA where it does not take a lot more to cross that line. And just to maybe kind of assuage some fears, because a lot of these jars got really full with a whole lot of these, risk factors that are this big, that are the really big ones that skyrocket someone's risk, are rare in the population. Generally speaking, with some exceptions, the more impactful, the more risky a factor is from a genetic standpoint, the less common it is out there. A person's DNA is not full of these. Thank goodness. But they are there, and they are impactful. And looking at a person's family history can, for some people, help uncover the fact that those might be hiding in those jars that we might be able to find. And so that's why we use family health history, that it can help us inform our risk of disease. It helps us answer the question of what's the chance that I have genetic craft palms in my jar, and how big are they if they exist? And so here's some things for you as you reflect on your family history, here's some things to think about. The diseases that are in your family history, the diseases that you're worried about and wanting to understand your risk for, the first question is, how genetic is that disease, right? Of that jar, how much of it is blue and how much of it is yellow? Because if it's influenza, your family history is not going to help, right? But if it's Huntington's, it's going to help a whole lot. But most diseases fall somewhere in between. And so for any disease out there, you can probably go on the internet and go do a little bit of digging and find out for that particular disease how much of a person's risk is contributed by the blue versus the yellow, the genetics versus the environment. So this is a chart of coronary artery disease. We've been picking on that one a little bit already. And it's about half and half about your risk being genetics versus environment. Other diseases, so this is Crohn's disease. It has a little bit more of a genetic component to environment. And this is autism over here that has an even larger genetic component. However, for each one of these are jars that look like this. So these genetic components are not really big craft bombs. It's a whole bunch of little ones that make up those blue sections. But if a disease that you're thinking about and concerned about your risk for, if it has a significant genetic contribution to its risk, then your family history may be a really nice tool to help you think about whether or not you've got genetic risk factors in your jar. So if you do want to go online and you want to go looking up this information, the term that would be really good to put in that Google search bar is this big word up here called heritability. It's a big word, but what that is this chart, right? It asking the question for that disease, for coronary artery disease heritability, what's the percentage of a person's risk that's controlled by genetics? So that'll help get you that number. So assuming the answer is yes, there is a genetic contribution to that disease, the next question is to look at your family history and ask the question, how abnormal, how different is my history from what you would expect if it was random chance? How common is that disease in the population, right? Coronary artery disease, pretty common. Having that in your family health history by itself is not a big red flag to me. You've got to compare your history to what you would expect and see how different that is. That might point to the fact that there might be some underlying risk factors that are being passed through your family. So we talk a lot about red flags in family histories, and there's no perfect list that it says if you have this in your history, that means you've got a genetic risk factor. But things that you're looking for are really all around how does your family history look different than you would expect otherwise? Do you have more people in your family affected than you would expect? We said earlier that women, that our risk of breast cancer is 12% lifetime. So you would expect for a typical person's family history for the rate of breast cancer to be in women about 12%, give or take, right? But if you have, if you've got a bunch of women in your family and that rate is higher than that, then that's more than you would expect. Do you have disease that's happening earlier than you typically expect that disease to happen? Breast cancers in people's 30s or 40s, Alzheimer's disease in people's 40s or 50s, right, where things are happening earlier. That kind of checks out with the thought exercise, right? That if you've got someone who at baseline, their jar is already pretty full, so it doesn't take a lot more to cross the threshold, that can happen earlier in life, right? Less time has to pass to accumulate those risk factors. If you've got body organs that you have 2 of them and you've got disease happening in both, bilateral breast cancer, that kind of thing, makes you think maybe there's risk factors that play. Diagnosis in the sex that's less likely to be affected, that's like the male breast cancer situation. And disease in family members where you know that that there are not other risk factors, that there's not a lot of environmental factors at play. So example, lung cancer in a non-smoker, right, where we know there's a really big environmental risk factor tied to that condition, and if you have someone that does not have that but still got it, right, it increases the chance that maybe there's some genetic risk factor that's also helping fill up that jar. So these are things that, if these are present in a family history, that makes it more likely that there are some of these these blue craft palms in your jar. And so the question is then, well, can we go find them? Is there genetic testing that might be useful to not just assume they're there, not just think, okay, maybe I've got an increased risk, but could we actually go and do a genetic test to specifically find it and know what it is, which can then really help us quantify and know what a person's risk is and be able to help inform other relatives and all of that. Sometimes we can. Genetic testing, DNA tests are pretty good, or are best at finding the biggest craft palms in the jar, right? The bigger ones are the ones that, we've discovered to be able to test for and are able to find most easily. And so things like doing genetic testing for BRCA1 and BRCA2 genes, testing for that CHEK2 or that ApoE for Alzheimer's, like those are genetic tests that are available that can help identify some of these larger risk factors and be able to help inform risk and make decisions about it. But one word of caution there, that genetic testing is not all the same. I see a lot of nods, like of course it's not. Somebody needs to go tell the primetime TV networks that. Because you hear all the time, well, they had the genetic test. There's not the genetic test, right? There's lots of genetic tests, and maybe you've got family members, or maybe you yourself have had a genetic test that's trying to find these risk factors, and that's an important part of your family history to be documenting too, so that you know what's been looked at and what hasn't. That there are genetic tests that are teensy-tiny, where you're just looking at one spot in the DNA, or just one gene, or multiple genes, or all of your genes, or all of your DNA. It gets bigger. But if you have a relative who maybe you have a family history of breast cancer, and you know somebody had the testing for those breast cancer genes back in the early 2000s. They're sitting about right here, right? Maybe we knew about BRCA1 and 2, but there's a lot of other breast cancer genes, risk-causing genes, that we know about today that we didn't know about then. And so knowing what family members have been tested for and knowing whether later down the line we need to do more testing, right? Because over time, we're going to learn more and more about these risk factors and be able to test for more and more of them. And oftentimes today, family history is used as a bit of a gatekeeper for genetic testing. Maybe you've experienced this. Maybe you've gone to a doctor's office where you filled out your information and they've said, well, based on that, we want to order a genetic test. This happens really often where doctors and insurance companies are using family history to decide who gets genetic testing, who would benefit from genetic testing, because they are wanting to they're wanting to provide that care to the people that have the most likely chance of it being useful or helpful. It's not that is a that works most of the time, but as we're about to talk about, not all the time, right? And we are quickly kind of shifting towards, in medicine and in genetics, towards maybe we need to open these gates a little bit further. But it is true, family health history can help us understand what's the chance that test is going to find something, what's the likelihood that you have risk factors that can be found. But as we'll see in just a minute, just because you don't have a family history doesn't mean your jar doesn't have even some pretty sizable blue craft balls in it. And part of that is because there's some big limitations that come with family history. Not everyone knows their family history, right? There's a study that was published a couple years ago. This is data from the Big All of Us research program that this particular chart is from, where they asked about 120,000 Americans who were a part of this research study. They asked them, how much do you know about your family history? And it was totally self-report. And about 37% said, I know a lot. 60% said some. And if I'm doing my math right, 3% said none. But one of the really interesting pieces of this study was that they looked at what are some of the things that make it more likely someone doesn't know a lot about their family history. Any guesses? Being adopted, yeah. Being male was one. That dramatically reduces. It's true. I'm sorry, that's what the data shows. All the males in this room are here tonight, so I'm assuming that's not representative of this population. But yeah, being male, but also being not white, also being of lower socioeconomic status, were also drivers of people not knowing their family history. And so that's striking in that, and something that we have to keep in mind, and that the medical system has to keep in mind, that relying too heavily on family history as a gatekeeper to care can further exacerbate health disparities, because that is not all created equal in terms of people's understanding and knowledge of their family history. But even for people who do know a lot about their family history, it doesn't always tell the whole story. That for a number of reasons, people can have, even sometimes, really big genetic risk factors that when you go and look at their family history, it doesn't tell the story. Maybe there are gaps in what they know about their family and relationships, but also maybe they come from a small family, and by random chance, people's jars just didn't fill the rest of the way up. Maybe you're talking about something like breast cancer, and you've got a family that's full of males. There's all kinds of reasons that the family history might not tell the whole story. And here at HudsonAlpha, we have watched this play out firsthand through a couple of projects, but I wanted to highlight this one right here. That's the Alabama Genomic Health Initiative. And this is a study that's funded by the state of Alabama. It's a collaboration between us at HudsonAlpha and our colleagues down at UAB, where we've been doing genetic testing through a research study for kind of the general population of Alabama. I won't go into all of those specifics, but through that study, the people that were participating, we test them for these big genetic risk factors for diseases like cancer and heart disease. And we also ask them about their family history when they enroll in the study. And a couple of statistics that are striking to note of the people in the study, which might be a little bit enriched for people with family histories. That might make someone more likely to do a study like this. But nearly half of the people that enrolled in the study had something in their family history that made us raise a red flag. That would mean, hey, maybe we need to be looking more deeply for some of these genetic risk factors. In about 1.5% of those participants, we found one of these big risk factors. So like I said, these are not super common, but 1.5% of this population we found them in. But here's the key takeaway. Of the people that we found a large risk factor in themselves, only about a third of them had a family history that made sense for this. Now, a lot of them actually had something else in their family that made us go, oh dear, that had nothing to do with what we actually found. So fascinating, right? Family history can help us inform risk, but not having a family history does not get you out of the woods of potentially having genetic risk there. And family history and genetic testing don't always tell the same stories. For many of those families and those people in Alabama Genomic Health Initiative, their best amount of risk information came from both. Having us look at their family history and help find flags there that put them at an increased risk, and doing genetic testing, that they're not substitutes for each other. In the best of worlds, you can actually use them together to assess risk. And for people who have genetic testing, because maybe we found some of those red flags in their history, and we went searching for large risk factors, knowing that person's family history helps us understand what happens when their results are boring, when we don't find anything in their test result. And for people who have a family history, that there's a red flag there, if we do genetic testing and we don't find an answer, we are not saying you're out of the woods, right? Your risk is no higher than the general population. For a lot of people, we are telling them you're probably still at an increased risk, right? Because we haven't explained what's happening in your family. And there's a chance there's a risk factor we just can't find with our current technology. And so for people with a family history, even with negative genetic testing, there's still reason to be concerned and on alert that the risk might be higher than the general population. But if you don't have a concerning family history and you have negative genetic testing and we don't find any big puffballs, yeah, you're probably at a general population risk, best we can tell. And we've been talking about cancer risk today. We've been talking about some of the cardiac things. We've been talking about Alzheimer's. You might have noticed that I haven't been giving a lot of examples for disorders like autoimmune disease, mental health illnesses, most of the cancers that happen at older ages, diabetes. There are lots of conditions like those that when we look at their heritability chart, there's a pretty big genetic piece of the pie. But if you were to come into a medical clinic, there's not any testing that we could actually offer, where we are totally reliant right now on family history because we're still trying to chase down these over here, right? Those are really complicated stories that there's not enough larger risk factors that we could actually go hunt for. And it's frustrating because some of these conditions up here we know run in families. They can cluster in families. We see that and we say, yeah, there are almost definitely some underlying genetic risk factors. We just do not have the tools to be able to find them, and enough of them that would actually help us use that to inform the next generation's risk. There's work being done to do that, but it's a really complicated puzzle, right? When you've got a whole bunch of tiny risk factors inside a jar, to get a person's risk, you've got to put them all together. Talk about complicated math. People smarter than me are working on that, and there is a whole area of study around trying to develop what are called polygenic risk scores, which is really exciting, but it is still in its infancy, where there's an attempt to try to pull together the information from lots and lots and lots of the tiny risk factors and assemble it together into one risk score for that person, for that disease. It's coming, but it is not out there in clinical practice yet, and there's still a lot of gaps that are in those jars to be filled out. But one tiny piece of evidence towards this that I wanted to show you at the power that this could have in helping us inform risk for some of these these complicated diseases with tons of tiny risk factors. This is a chart from a paper that was published just a couple of years ago in 2021. And this was a study looking at the polygenic risk scores for coronary artery disease. So this situation right here. And what they were doing was they were looking at the relative importance, how well these risk factors predict whether someone is going to get sick with artery disease. And going down, you can see over here is better. It's more predictive. It's more important. You've got some of your classic risk factors like smoking, diabetes, BMI, hypertension, high cholesterol, right? These are all these guys, right? Environmental risk factors that can contribute to that risk, and those are important. And then this one right here, this is the polygenic risk score. So using current knowledge and assembling a person's genetic risk for artery disease, it actually outperforms each of those by itself. But if you combine all of the conventional risk factors, you're beating it. But the best case is actually to combine it all together, where you're combining the genetic risk and the environmental risk together into one bundled score. Pretty cool, right? Yes, sir.
I was wondering why that is in a psychiatry journal.
I have no idea. The question was, why was this published in a psychiatry journal? Quite possibly, this particular study was looking at polygenic risk scores for several different disorders, and this was one, and maybe some of the others were more psychiatric related. But that's a good question. I don't know. And so especially for things like coronary arteries, where if you think back to that heritability chart, it was kind of half and half genetics, half environment, that we here at Hudson Alpha care a lot about the genetic pieces. That is the place that we are playing in trying to discover and identify more of these genetic pieces. But those are not the pieces that we as humans have say over or control over. And even for things that have big risk factors, we can't ignore the things that we can control, those environmental, those lifestyle factors. And that's part of why we want to know our risk, is so that hopefully we can take steps to try to mitigate that risk. So here's my call to action for you. It is now September 10th. Thanksgiving is coming up. Christmas is coming up, right? This looks amazing. But we have opportunities all year long, but especially coming in during the holidays, that we get together with our family to maybe, probe a little bit and try to use those opportunities to talk to relatives and gather that family history. Think about it as a gift almost to that next generation that's going to want that information. They might not care about it now. They might roll their eyes, but document it and have it there and pass it on so that the next generations can use that to kind of empower their health and disease risk going forward. So collect that information and then think about, are there red flags in your history that you need to talk to care providers about, talk to your doctors about? Is there genetic testing that should be considered? Are there things that should be different about how you're screening for disease or ways that you can prevent diseases based on what you're seeing in your family history? In the handouts and up on the slide, I've put a few resources that are out there and available to you. This top one, to call attention to it, this is a tool that was developed by the Surgeon General that helps build and document your family history. It actually will create one of those really pretty charts for you, but by asking you a whole bunch of questions, and you can actually log in and have an account so you can go back in and add information later. But if that stresses you out, just pull a piece of paper and a pen and start writing, right? And save it for the future. But as far as using that to inform your health, talk to your doctors about this, or use some of the resources that are available online that are from good sources that help you figure out how to tease, is your family history striking or not, and what should you do next? Because really the question that people, come back, too far. Often people say, well, what about, what does it mean if my relative had X at age Y? And the answer to that, what that means for a person, varies wildly based on how those blanks are filled in, right? How genetic is the disease? How different is that age that they were diagnosed? That can really swing one way or the other depending on what that condition is. And so with that, I want to wrap the same way we started. And as we think about, or as I think about what my family history means for me and how I go through the thought exercise of my history. So Mom had a brain tumor. If I were to go and look online and say, what's the genetics of, and specifically she had an oligodendroglioma, we'll say that 3 times fast, I would find out that this is a condition that doesn't run in families usually. That this is one of those fluky things that happens, and having a family member with this particular type of brain tumor does almost nothing to my risk of having a similar story, which is good news. My grandmother had breast cancer. Now, if you remember, she was in her 60s when she was diagnosed. She might have had it for a good long time before that, but we're not sure. And what I didn't share with you is if we dug further out in my family history, on my dad's side of the family, there would be more breast cancer there at younger ages, even one bilateral, that starts getting more and more striking. Now, my grandmother passed away in 1983. That was before Mary Claire King ever even published that original math paper about finding breast cancer genes. So there was no testing that could be done for my grandmother. Some of my other relatives that have had the younger breast cancers have had good testing, and nothing's been found. So at this point, we haven't found a specific blue puffball, right, that's explaining the history in my family. So for me, there's not really any testing I can do to better inform that. The best people in the family to go have testing to try to find the puffballs are the people who have been sick themselves. And if we didn't find it there, it's highly unlikely that it's going to be hiding in my DNA when it's not in theirs. But there is absolutely a chance that there are blue puffballs hiding that we can't detect. And so where I sit with that history is with my risk is quite possibly somewhat higher than the general population. It's unsatisfying because there's no number I can give to it, but it's something that based on my family history, even with negative genetic testing in the family, that I'm still sitting with an elevated risk and able to monitor that and just talk to my doctors about how do we get ahead of that and how do we think about early screening and earlier diagnoses. And maybe, and also we wait for technology to get better, right? And continue to search for puffballs as new tests come up. You're never gonna look at a puffball the same, right? Right. Okay, I do want to point you to, so if you're sitting there tonight and thinking, oh my, there are questions I still have. Based on what we've heard tonight, I think I actually might need to go on a hunt for blue puffballs, right? Maybe I need to think about, is there genetic testing based on my family history? Here are some local resources. This top one, this is the clinic on Hudson Alpha's campus. This is our genomic medicine clinic that absolutely can see people clinically and talk about family history and whether genetic testing is appropriate or not and what risk might look like. If the questions are specifically cancer related, another great resource here in Huntsville is Clearview Cancer Institute, where they've got genetic counselors who are really good at assessing risk, doing testing, and then helping manage what that risk is, regardless of whether the tests are positive or negative. So you can call either one of those clinics and say, hey, I want to know more about, I'm worried about my family history of X. But then also your own primary care and other medical specialists are trained to and should be asking these kinds of questions, maybe to send you one of these other places, or maybe to manage some of that themselves. But ask those questions of them and see what they think about your history as well. As we wrap up, I wanted to point out two other initiatives, ways that you might want to get involved. And this one that's up on the screen right now, there's actually flyers out in our lobby that you could pick up if you want to learn more about. This is a flyer about a Parkinson's disease research study that scientists at HudsonAlpha are embarking on with an attempt to develop better ways to diagnose and monitor Parkinson's. But what they're looking for this study is they actually are looking for people to sign up and be a part of the study that don't have Parkinson's currently. They're actually looking for healthy controls. What they really would love to find are healthy controls that have a relative with Parkinson's, that actually has Parkinson's somewhere in their family history. But you can also be a part of the study with no Parkinson's in your family history either. But if you're looking for ways to get connected with HudsonAlpha and be a part of the scientific research, that's an option. We're recruiting out of the Smith Family Clinic for Genomic Medicine here on campus. My understanding is that it's a blood sample is what you contribute to participate. So I wanted to call attention to that, especially if you're sitting here tonight and you have Parkinson's disease in your family history and are wanting to contribute to us better understanding that disease. And then HudsonAlpha also for a number of years has an initiative called Information is Power. And this is a program that got started, the origin story of Information is Power is Dr. Mary Claire King, remember her? She was here at HudsonAlpha a number of years ago speaking at an event that's a fundraiser for breast and ovarian cancer research and looked at us and said, Huntsville's a smart place. And I think you guys can be the ones that can figure out how to offer cancer risk genetic testing, looking for these guys, right, to anybody. So open the gates, stop making family history a barrier. Let's make this available to anybody who wants to know it. At the time, that was really hard. But we said, okay. And we developed Information is Power and created a program where individuals in our community can get access to cancer risk testing, genetic testing at low or no cost. The way this currently works is that there's a set of our population that can get this testing for free. It's folks that are between the ages of 28 and 30 in the 5-county region up in it's Madison County and all of our surrounding Alabama counties. But for everybody else who's not 28 to 30 years old, we're working through some logistics around how that can be made available for not no cost, but low cost. So keep that in mind and look on the internet for more information or reach out to us if you've got questions. But if you're sitting here tonight saying, yeah, I really want to know about my cancer risk because of stuff happening in my family history, my encouragement to you is this is more of a screening test for folks in the general population. If you've got strong risk factors in your family history, go see somebody clinically to get genetic testing through a doctor's office, either at CCI or with us at HudsonAlpha. Okay, so I'm going to wrap, but I'm going to hang out down here so we can continue to have conversations. I want to point you to some upcoming events. I hope some of these might be on your radar already and that you're planning to come to 1 or 2 or 4 of them. There is the Tie the Ribbons Luncheon. That is HudsonAlpha's fundraiser for breast and ovarian cancer research that's happening on November 7th. We're having an event. I hope many of you will get invitations to that. It's our Alumni Association Appreciation event. What that means, you've probably gotten emails about becoming a member of Hudson Alpha Alumni. What that means is that you're a supporter of what we do in education. And so we have a night every fall where we get to celebrate together all the things that we've done in education, not just with the community, but with students and teachers and interns and all the things that we do, and celebrate together and say thank you. So if you're not a member of Alumni, that's where you can go to become one. But then also kind of pointing ahead, there is a really special night coming up in November here at the Jackson Center where we've got a special speaker coming, Dr. Harold Varmus, Nobel Prize winner, for his discovery in Onca genes that help drive cancer. He will be here talking to us. And then mark your calendars for our first Hudson Alpha U of next year on February 25th. So with that, I want to say thank you. Like I said, I'm going to hang out down here, and our goal in education and our goal with Hudson Alpha U is to be your resource, that you guys have Hudson Alpha that you can come to with questions, and that we can help you navigate genetics and life. And so I just want to say thank you for being here tonight and letting us help kind of bring science to life for our community.